Welcome to lecture number 7 of fuzzy sets, logic and systems and application. So, in this lecture nomenclatures used in fuzzy set theory will be covered. So, here are few nomenclatures that are listed. So, we have here 15 nomenclatures that are commonly used in fuzzy set theory, and in this lecture we will be discussing support, core, crossover points, height, normality, subnormal fuzzy set. So, let us now discuss the nomenclatures used in fuzzy set theory one by one. So, the first one is support. So, what is a support? So, the support of a fuzzy set A is the set of all the points small x in universe of discourse capital X for any associated membership function such that mu of x. So, since we are talking of a fuzzy set A, so that is why we are saying here the mu A. So, this A represents the fuzzy set, the name of the fuzzy set. So, mu A of small x. So, mu A of x should be greater than 0. So, support of A is written here. We see that support of A is equal to the set, the collection of all the x, this x is nothing but the generic variable values, and this has been drawn from the universe of discourse. So, we will not be taking any value which is not there in the universe of discourse, and then this is here this all the values of x for which the mu A x greater than 0. So, it is very clear that if I have a fuzzy set, let us say here. So, this fuzzy set has here for the value of x 1, the mu x 1 is 0. See here, the mu x 1 is 0, and then at x 2 mu x 2 is also 0. So, and I will be writing A here and A here because we have taken a fuzzy set A, and this mu corresponds to the fuzzy set A. So, that is why mu A has been written. So, now these 2 points x 1 and x 2 will be excluded from all the values of x here, which has the membership values more than 1. So, this point will not be x 1 and x 2 point will not be covered in the support of a fuzzy set. So, if we have a continuous fuzzy set here as it is shown here, so we will have all those points, because since this is a continuous point, we will have, as far as the number of elements are concerned, we may have the infinite number of points. So, that is why it is shown by a line here. So, we can clearly represent this line as the support of a fuzzy set A, and this fuzzy set is a continuous fuzzy set. So, let us now take an example here where the fuzzy set A is a discrete fuzzy set. So, if we take a fuzzy set here as A is equal to this we have a set fuzzy set which includes all these points where the first element here is the generic variable value, and then here the second element is the second element of this pair, the value, and then the corresponding membership value. Similarly, we have 1, 2, 3, 4, 5, 6. So, in this discrete fuzzy set we have 6 elements, and so if we look at this fuzzy set, it is very clear that all these generic variable values 5, 6, 7, 9, 10, 11, they have their corresponding membership values all greater than 0. And as per the definition, if we are interested in finding the support of a fuzzy set, especially here this fuzzy set is a discrete fuzzy set. So, we can write the support of a fuzzy set A for this case will be the collection of all the points for which the corresponding membership value is greater than 0. And we can clearly see here all the points, all the 6 points here, first, second, third, fourth, fifth, sixth, all these points, all these generic variables have their corresponding membership values greater than 1. So, it means that the support of A will have a set of all those generic variable values. So, it means if we would like to write the support of a fuzzy set, especially the discrete fuzzy set, then we will have here for this case, for this discrete fuzzy set, we will have the set of points 5, 6, 7, 9, 10, 11. So, this way we will write the support of a fuzzy set like this. Now, let us discuss the core of a fuzzy set. So, the core of a fuzzy set is the set of all the points in the universe of discourse such that mu A x is equal to 1. So, this can be represented as, if you would like to write the core of a fuzzy set, and this will be equal to the collection of all the points or the set of all the points for which the corresponding membership values are 1. We can very clearly understand the core of a fuzzy set like this. If we take a fuzzy set A, this is a fuzzy set here, and we would like to find the core of this fuzzy set, we will take the collection of all the, we will take the set of all the points here for which corresponding membership values are 1. So, we can clearly see here for this membership function, which is a trapezoidal membership function, and of course, this is a continuous fuzzy set. So, we can say that this line x 1 till x 2, we have for each and every point which is coming in between, will have the membership, their corresponding membership values equal to 1. So, this line will represent the core of a fuzzy set here for this fuzzy set. So, let us now take an example to better understand the core of a fuzzy set, especially for the discrete fuzzy set here. So, let us take this example. A fuzzy set A here is given by A, see here, and this fuzzy set has 1, 2, 3, 4, 5, 6 points, and these points basically are the fuzzy points. Fuzzy point means it has two values. This is a pair. The first value, as we have seen in the previous case also, previous example also, the first element here is the generic variable value, and then the second element here, the pair, the second element of this pair is the membership value, corresponding membership value. So, if we look at this fuzzy set, we have 6 elements, 6 points, and if we see, we find there are 2 points, there are 2 generic variable values for which the corresponding membership values are 1. So, one is here, the first one is here, and then the second one is here. So, as per the definition, core of a fuzzy set is the collection of all the points, all the generic variable values for which the corresponding membership values are 1. So, that is why here if we apply that, we will find 8 and 11, and we can write here as a set. We can write core of a fuzzy set here, core of a discrete fuzzy set is collection of the generic variable values which are 8 and 11. So, this is very simple, very clear. So, for discrete fuzzy set, if we are interested in finding core of a fuzzy set, we can very easily collect those values, those generic variable values for which the membership, the corresponding membership value is 1. The rest generic variable values we just leave aside. So, we only take the generic variable values here, and this is very important here to be noted that when we are writing either support of a fuzzy set or core of a fuzzy set, we only write the generic variable, the collection of the generic variable values. We do not write the corresponding membership values also along with the generic variable values. So, we only write the values of x, and that is how we get the support of a fuzzy set and the core of a fuzzy set. So, now let us move to another nomenclature that is used in fuzzy systems theory, the crossover points. So, the crossover points of a fuzzy set A is the points x in universe of discourse capital X, at which mu A x is equal to 0.5. It can be represented as the crossover of A, and this crossover of A will give us a set of all the values of x, and as we know this x is nothing but the generic variable values, and these values will be only those values for which mu A x is equal to 0.5, means the half. So, if we take an example here to understand the crossover of a fuzzy set A here. So, if we have a fuzzy set A, this is a fuzzy set A, this is A fuzzy set, and we try to find the point corresponding to which the membership value is 0.5. So, x 1 is the point here corresponding to which the membership value is half. or 0.5. So, x 1 for this fuzzy set we have two values x 1 and x 2, for which we see here the membership value is 0.5. Similarly, here if we would like to understand better, we can refer to this example for crossover points. So, if we have a fuzzy set A like this, here we have a fuzzy set, and in this fuzzy set we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements or 11 pairs. So, if we are interested in finding out crossover points for this fuzzy set, we only look for the generic variable values for which the corresponding membership values are 0.5. So, in this fuzzy set, this is a discrete fuzzy set obviously. So, we see here in this fuzzy set 7 is the generic variable value for which the membership value is 0.5. So, this is the first generic variable value that is we have found, and then let us now look at some other value for which we have the membership value half. So, we see here 14 is another point for which the membership value 0.5. So, this way we find 2.7 and 14 and their corresponding values are membership values are 0.5. So, that is how we write here the crossover of a fuzzy set is the a set which has 7 and 14. So, this way we get a crossover of a discrete fuzzy set. Now, here is a representation of core, support and crossover points of a fuzzy set. So, if we take a fuzzy set, let us say some fuzzy set which is trapezoidal fuzzy set here. So, if we are interested in core of this fuzzy set, we can clearly see here that as per the definition, core of the fuzzy set is represented by the line C D here. So, if we look at this point here, so right from C we have all the generic variable values corresponding to which the membership values are 1. So, that is how, and this goes till C till D. So, this way C D will represent the core of a fuzzy set, and this fuzzy set here is the trapezoidal fuzzy set, which is continuous fuzzy set. And if we are interested in finding the support of a fuzzy set, so support of a fuzzy set is, as per definition, it's a collection, it gives us the collection of all the generic variable values for which their respective membership values are more than 0. So, this will start right from the 0 plus, right from 0 plus means this will start from A. A is the point where we have the membership value, if the A is the point, let us say if it is x A. So, this x A will have its corresponding membership value 0, but x 1 plus epsilon will have its corresponding membership value more than 0. So, just after A, all the points and just before F, all the points of this generic variable will be included in the support of a fuzzy set. So, this way if we are interested in finding the fuzzy set, we can say this support of this fuzzy set is represented by this line, the red line, and please please look at the ends of the A and F, I mean this line. So, we see here the hollow circle. So, we see hollow circles at both the ends. It means that the generic variable value for which the mu x is 0 is not these are not included at both the ends. So, this way we clearly understand what is the support of a fuzzy set, and then when we are interested in finding the crossover of this fuzzy set, of course, we will find the points on the fuzzy sets, the generic variable values on in this fuzzy set for which the membership values are 0.5. So, we see here clearly that we have B point and E point for which the corresponding membership values are 0.5. So, that is how the crossover points are B and E. So, this way we here make the clear distinction among the core, support and a crossover points of a fuzzy set. Now, let us discuss the height of a fuzzy set. So, how can we find a height of a fuzzy set? So, height of a fuzzy set first of all is defined by the h g t of A, and this f g t of A is equal to the max of all the values of membership. This is fuzzy set B, this is fuzzy set C. So, A is represented by the blue line and B is represented by the red line, red color, and C is represented by the violet color. So, if we talk of A, so we clearly see that the highest value of membership here goes till 1. So, if we take all the membership values corresponding all the generic variable values, we will find the max of the membership values of this fuzzy set A. So, I can write it like this, like if I have mu A of x here, and if I take this by the middle bracket like this, and if I take max of this, I am going to get 1. Similarly, if we talk of height of the fuzzy set B, here for B fuzzy set, the height of B fuzzy set will be 0.4, because if we take all the corresponding membership values and take the max of these, we will be getting 0.4. Discrete fuzzy set can be understood by this example. So, if we take a fuzzy set A here, so this is fuzzy set A. So, if we look at all the values of the membership here, membership values. So, we see that these are the values of these are corresponding membership values, and if we collect these values and take max of this, we are going to get the max of mu of x, mu A x, and this will be equal to 1 for the fuzzy set A. So, this way the height of the fuzzy set here will be this we can write as h g t of A. So, HGT of A will be 1. Similarly, what will be the height of fuzzy set B? So, by looking at the fuzzy set here, we can clearly see the highest value of membership that it has, it contains is 0.9 in this membership, in this fuzzy set. So, the height of fuzzy set B will be 0.9. Similarly, for C fuzzy set, the height of C fuzzy set will be 0.7 in this example, because the highest value of the membership, the maximum value of membership values, or I can say the if we take max of all the membership values that it contains will be 0.7. So, this way we clearly find the height of the fuzzy set. Now, let us look at the, let us now discuss the normality of a fuzzy set is nothing but it is defined as a fuzzy set A is normal if its core is non-empty. So, this can be defined in other words as we can always find a point x in universe of discourse capital X such that mu A x is equal to 1. So, what does this mean here is that if we have a fuzzy set A, let us say, and if this fuzzy set A has at least one point, one generic variable value for which or its corresponding membership value is 1. So, at least we should have a membership value is equal to 1. So, in other words, we can understand this as that if the height of a fuzzy set can go up to 1, the fuzzy set will be a normal fuzzy set. So, we can see here in this diagram, we have a fuzzy set A here, this is the fuzzy set, and if we see here x 2 is the point, x 2 is the generic variable value for which we have the membership value 1. So, if we have such a case where we are getting a point, at least a point like this, we can say the fuzzy set is a normal fuzzy set. So, there may be a case when we may not be able to find any such point for which the corresponding membership value is 1. So, this kind of membership, this kind of fuzzy set is referred to as a subnormal fuzzy set. So, here if we corresponding to this fuzzy set A, the core of A is x 2, and since the core of A is non-empty, of course, because we are getting at least a point x 2 for this fuzzy set. So, we can say the core of A is non-empty. So, this fuzzy set is a normal fuzzy set. There may be a case where core of a fuzzy set empty. So, such a fuzzy set is referred to as subnormal fuzzy set. So, let us now take this example here A B of discrete fuzzy sets A B C, and we see here that if we take a fuzzy set A and we clearly see that we have in this fuzzy set we get a point, we get a fuzzy point where we get the mu corresponding mu, the corresponding membership value 1. So, it means that we have at least one point present, one fuzzy point present, one point present for which we have the corresponding membership value 1. And please understand, when we say at least, it means if we have multiple such points present, then also this fuzzy set will be a fuzzy set, a normal fuzzy set. So, at least means at least one such point is present for which the corresponding membership value is 1. So, A is a normal fuzzy set, A is a normal fuzzy set, this is a normal fuzzy set. Now, what about B fuzzy set? So, let us now check all the points here for fuzzy set B is the B fuzzy set. So, in B fuzzy set if we see here in the fuzzy set all the points. So, we do not find any such a point, such a membership, such a generic variable value for which we get the membership value 1. So, we can say this fuzzy set is not normal, or we can say the B fuzzy set is subnormal. Similarly, now let us check a fuzzy set C. So, just by going through the all these points here which are in the in this set, the fuzzy set. So, we see that we get here this point. So, the generic variable value 13 has its corresponding membership value 1, and so at least we have one such a point present, such a generic variable value present for which we have mu of the membership value is 1. So, that is why we can say C is a normal fuzzy set. So, this way we can clearly check all the normality of a fuzzy set, or normality in a fuzzy set we can check. Now, we have a diagram here, and this figure has the fuzzy sets A, B, C. So, let us now clearly check whether A is a normal fuzzy set or a subnormal fuzzy set. So, A, B or C, all these are normal fuzzy sets or subnormal fuzzy sets. So, if we see A here, A reaches up to A is high, the height of fuzzy set A has or is 1. So, we can say here the height of fuzzy set A is 1. So, it means fuzzy set A reaches up to 1. So, it means its membership value, the highest membership value, the maximum of all the membership values is 1. So, that is why we can say the core of this fuzzy set is non-empty, and if the core of this fuzzy set is non-empty, it means that this fuzzy set is a normal fuzzy set. Whereas, if we see here, we will not be getting any point, any generic variable value for which we get mu x is equal to 1. So, this will be a subnormal fuzzy set. Similarly, here C also will be the subnormal fuzzy set. So, only A is a normal fuzzy set, right. So, because the core of A, which is written here. So, core of A this is non-empty, non-empty. And if we talk of C, so since core of C is empty here and core of B is also an empty set. So, that is why these B and C both the sets are subnormal fuzzy sets. At this point we would like to stop for this lecture, and in the next lecture we will be discussing the remaining nomenclatures used in the fuzzy set theory. So, it means we will be moving ahead to discuss remaining nomenclatures. Thank you.